Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ashraf Benjamin Gulam. My friends Normadiha and Wan Aisha. Today we have chose Bleach as our common household everyday product. And without wasting time, let us begin with overview of bleach. Bleach is widely used chemical solution known for its powerful disinfecting, stain removing and whitening properties. The most common type is sodium hypochlorite in liquid form, but other variants such as calcium hypochlorite and hydrogen peroxide serve similar purposes. It is extensively used both at home and in industrial applications to kill bacteria, remove mold, and eliminate tough stains. While highly effective, bleach must be used with caution due to its corrosive nature and potential health hazard if not handled properly. So do not mix with ammonia or acids cause it will produce harmful gases, and use in well-ventilated areas, and wear protective gear if needed. Now, we will go for the significance in daily life. The first one, water purifications. This disinfects non-potable water during supply interruption or contamination. Also keeps swimming pools free of waterborne germs, preventing illnesses like diarrhea and swimmer's ears. The next one is cleanings and disinfections. Bleach effectively kills bacteria, viruses, and fungi, making it essential for sanitizing surface, especially in kitchens and bathrooms and hospitals. It is also helps prevent the spread of colds, flu, norovirus, and other infectious diseases. The next one, healthcare medical use. It helps with disinfects reusable medical equipment in hospitals, labs, and clinics. Also prevents the spread of infectious disease in hospitals, labs, clinics, and nursing homes. And the last one is safe food preparation. Sanitize food production equipments, food preparation areas, and transportation containers. Used in grocery stores and restaurants to maintain hygiene by sanitizing food contact surfaces and preventing cross-contamination. Also, it destroys germs on raw foods when properly diluted in water. Now, I will be passing it on to Madiha to explain further.
Fun facts! Did you know that bleach played a crucial role in World War I? While chlorine gas was used as a deadly weapon, a safer form, sodium hypochlorite, was used to save lives. In 1915, Henry Dakin and Alexis Carroll developed Dakin solutions, a diluted bleach mixture used to clean wounds and prevent infections on the battlefield. Chlorine-based disinfectants were also used to sterilize drinking water, reducing disease outbreak among soldiers. This wartime discovery paved the way for modern antiseptics and water purification methods still used today. So the next time you use bleach, remember, it's not just for cleaning, it once helped save lives in war. See you again.
Thank you, Benjamin, for that awesome information. Hello, my name is Normadiha binti Asirazam, and for my part, I will be describing the chemical components and the functions of the product, which is, for us, bleach. First is the chemical components, sodium hypochlorite and ACLO. This is the active ingredient in most household bleach products. Sodium hypochlorite acts as an oxidizing agent, breaking down and removing stains, kills bacteria, viruses, and fungi, and also whitens fabrics and surfaces. Next is water, H2O. Water is the solvent in bleach, diluting the sodium hypochlorite and making it easier to handle and apply. Sodium chloride, NaCl, is the last one. Commonly known as table salt, sodium chloride is a byproduct of the bleach manufacturing process. It does not have an active role in the bleaching process, but it is present in small amounts. Next, I will be explaining the many functions of bleach, but I will only highlight 5 of them. First up is surfactants. Some bleach products contain surfactants to help spread the solution more easily and penetrate surfaces for better cleaning. The next one is stabilizers and preservatives. Various chemicals are added to bleach to extend its shelf life and maintain its potency. These can include compounds like sodium carbonate, which also help to buffer the solution. The bleaching of hair consists of hair lightening. Bleach is used in hair salons and at home to lighten hair color. It works by breaking down the natural pigment, which is melanin, in the hair, resulting in a lighter shade. This process is commonly used to achieve blonde or platinum hair colors. The removal of stains consists of 2: household cleaning and laundry. Bleach is commonly used to remove tough stains from various surfaces, including kitchen countertops, bathroom tiles, and laundry. It works by breaking down the molecular bonds of the stains, making it easier to wash away. The last one, laundry, where bleach is used to whiten and brighten clothes, especially white fabrics. It can effectively remove stains like coffee, wine, and grass by restoring the original color of the fabric. That's all for my part. I will be passing it along to Wan Aisha. Fun fact! In the early 20th century, approximately the 19,000s, the practice of bleaching flour was common, with chemicals like chlorine dioxide used to enhance its whiteness and softness. This process aimed to improve the aesthetic appeal and baking quality of the flour, making it more attractive to consumers. However, the use of chemical bleaching agents raised significant health concerns. Residual chemicals in the bleached flour could potentially pose risks to consumers, leading to increased scrutiny and regulation by health authorities. Over time, the negative health implications and consumers' demand for safer food production practices that led to the development and adoption of alternative methods. Modern milling techniques now utilize natural oxidizing agents such as ascorbic acid, vitamin C, or enzyme treatments to achieve similar results without the harmful effects associated with chemical bleaching. The transition from chemical bleaching to safer, more natural methods reflects a broader trend towards sustainable and health-conscious food production. This change has been driven by a combination of regular pressure, scientific advancements, and growing consumer awareness about the importance of food safety and quality. Additionally, this shift has had a positive impact on the environment, as the use of natural and non-toxic substances reduces the ecological footprint of flour production. The evolution of flour bleaching practices exemplifies how industries can adapt to meet both regular standards and consumer preferences, ultimately leading to safer and more sustainable products.
Hi, my name is Vanessa. So the next part will be on the chemistry on how bleach works. Here I will be explaining to you regarding the chemical process and the reaction that involved in bleach usage itself. So, as my friend explained to you before, bleach are widely used in our daily life. It could either be to disinfect contaminated drinking water or in food preparing. But the common use of bleach in our household is to remove stain and disinfect the surface in our home. And that's going to be our main focus for this part. I'm going to be explaining to you regarding bleach, disinfection and antimicrobial reaction, and also the whitening and stain removal reaction. So let's move on to the next one. So the first point is disinfection and antimicrobial reaction. So basically, this reaction involves oxidation process, and the common bleach that we use in our household actually contains sodium hypochlorite, which is a very strong oxidizing agent. So basically, this sodium hypochlorite will oxidize molecules in germs, bacteria, molds, or fungi, and eventually destroys them. So below here is a little bit of illustration on how this reaction works. So basically, I would like yourself to imagine you running in a marathon and you will be sweating a lot. So basically, your clothes will be absorbing all of the sweat, which will provide a very good environment for bacterial production. And so you decide to went home and put your clothes in a solution of bleach. So what will happen here? Basically, the sodium hypochlorites inside the bleach will attack the protein in bacterial cells. So you need to know that protein plays a huge role in cell. It provides structure support for the cell and also helps in DNA replication, which allows the cells to divide themselves. So once the sodium hypochlorite attacks the protein in the bacterial cells, the bacterial cells will start to aggregate. In other words, it starts to clump together. And eventually, the bacterial cells will be destroyed. And so that's it for this point. Let's move on to the next one. The second reaction will be on whitening and stain removal. So how does it work? Basically, sodium hypochlorite will break down chromophores. A little bit of side note here, chromophores actually refers to a chemical substance that can absorb light at a certain wavelength range. And as I mentioned to you before, sodium hypochlorite is a very strong oxidizing agent, which means it could remove one or more electrons from its reaction partner. In this case, it's the chromophores or the stains itself. So let's look down below at the illustration. We can see here there is a shirt that has stains, so we decided to put it in a solution of bleach. What will happen here? So oxidation reaction will happen where sodium hypochlorite will remove one or more electrons from chromophores, which cause the chromophores to change its chemical structure. And eventually, it will cause the chromophores to unable to absorb light. In other words, it will help us to clean our clothes, or in some worst cases, it could cause our clothes to discolor. So that's it for my part. I will let my friend to continue the next part.
Allow me to start first for potential environmental or health impact. For the first one, environmental impacts. If chlorine release. If chlorine gas or bleach enters water source, it can be toxic to fish and other aquatic organisms, disrupting ecosystems. Also, chlorine gas is harmful to the atmosphere, contributing to air quality degradation. The next one is health impact. Corrosiveness refers to substance ability to cause severe damage or destruction to materials, living tissues, or surfaces, meaning it can burn or destroy skin, eyes, and mucous membranes on contacts.
For my part, it is soil contamination for the environmental effect and skin and eye irritation for the health impact. So for soil contamination, improper disposal of bleach can lead to soil contamination. It affects plant growth and soil health. For health impact, it consists of skin and eye irritation. Direct contact with bleach can cause skin and eye irritation. Why? Because it leads to redness, itchiness, and also burning sensation.
As for my point, for environmental impact will be on ozone depletion. So for your information, inside bleach, there is a chlorine component that could react with our ozone layer to produce chlorine monoxide. Basically, chlorine molecule will be released into the air to react with ozone molecules, breaking it down to produce oxygen and chlorine compound. And this chlorine compound will react with another oxygen molecules to produce chlorine again. And basically, these cycles keep on repeating, destroying thousands of ozone molecules in our ozone layer, which will weaken our ozone layer. And as for health impact, it could cause respiratory disease. So inhaling gas that is released by bleach could cause our respiratory tract to be damaged and leads to disease such as ARDS, pulmonary edema, and also pneumonitis. all of those diseases are related to buildup of fluids in our lungs, and also inflammation happens in our lungs. And that will be it. This is our reference slide. And that's all from us. Thank you.